Flipped classes have become a passion of mine both in my teaching and in my research at Radford University. Now, when I think about flipped learning, I think about a process for which we're able to create collaborative, student-centered learning within the classroom. So by shifting out the lecture components into other forms of multimedia and lectures that they can watch outside of class. To me, what I found by doing this method is that students are more engaged in my class. They're willing to discuss concepts of mathematics more in the class, which is something that is very difficult to have occur in math classes. I also find that when I'm teaching, I find the classes to be unique in their own regard as to what we discuss and issues that arise, and I find that I'm able to quickly help students in the areas that they specifically need help, because as I am able to teach and walk around and see what's going on, I can see where there's any issues of struggle with my students quickly and effectively. From the success that I have felt as a teacher using flipped learning, that has branched out into my aspects of how I consider research and what I continue to research. This is both with students as well as with faculty. A lot of my initial work currently has been with elementary education pre-service teachers. I've completed 3 different studies at Radford with these students, and we've looked especially at the idea of classes that have not been flipped versus those that we flipped. And what we've noticed that academically the achievement has been better in some cases, or at least equivalent, but students that are in the flipped courses that with materials created by the instructor, their anxiety both of mathematics and teaching mathematics significantly decreased more than the comparative classes that had no flipped component to them. One interesting aspect is when we flipped a class using third-party materials, in this case it was the Khan Academy videos, students did not have that significant decrease in anxiety like they did when it was the teacher-created materials. And we surmise that part of that may be the fact that the materials maybe didn't align as well as when they're created by the instructor, and there may not be necessarily that connection that helps students build that confidence while they're watching the pre-course materials. In addition, we focus on the ideas of how flipped can help students in STEM majors. Currently, we've completed a pilot study with a Calculus 1 class, and we're currently analyzing that data to examine any impact that flipping had on achievement as well as the attitudes and beliefs of students in the STEM fields. And we currently have an NSF IU's proposal that's going to examine freshmen and sophomores as they enter into their major, and how integrating flipped classes into those major courses in biology, chemistry, physics, mathematics, how they can actually impact students' long-term achievement, long-term retention in STEM fields, as well as their perceptions about STEM and learning in STEM. Finally, though, for all these aspects to be effective, we need faculty that are willing to create these types of environments for their students as well. So part of that IU's proposal and what I've been working with here at Radford University with a high impact proposal is the idea of creating flipped institutes for faculty to help them learn what does it mean to flip your class, as well as what does it mean for what we do during class in comparison to when we were lecturing before. And during these proposals, my goal is to look at how does it affect their attitudes and beliefs about their instruction, but also about what it means for students to learn and how we can improve student learning long term. If you have any questions about some of the research I'm doing and about my instructional practices, you are more than welcome to contact me. I look forward to hearing from you.